Got it. Okay, good morning, everybody. This is Thursdays with Franco without Franco. My name's Jason Grogan. For those that don't know me, I run the other specialist team for the infrastructure and security side of OCI, as opposed to Franco, who looks after the data and integration and analytics side of the house. So today we're going to be talking with Chris, or Chris is going to be giving us a presentation on containers and Kubernetes and microservices. So without further ado, we'll pass it over to Chris to let him run through his presentation, and then towards the end of the session, we'll open it up for questions from the lovely people that have come along to hear Chris. So take it away, Chris.
Thanks, Jason. Hi, everyone. So quick intro. My name is Chris Bannayan. I'm part of Jason's team in the OCI Infrastructure Specialists. And today I'll be talking about containers, Kubernetes and our OKE platform. And we'll talk about some microservices as well. And hopefully if there's a bit of time at the end, we'll give you a quick demo on how we can scale containers and pods and do a quick demo of a DevOps pipeline.
Excellent.
So let me share my screen with everyone. Cool. Right. So our safe harbor statement slide, which is our standard one. So I'm
feeling very safe in my harbor. Very good.
We'll continue on. So I thought I'd start with this slide. And it is a busy slide. There's a lot of components here, but it's really just to give you an idea of the vast array of products we have for our developments, for our developers and our development platform. I will only be sort of concentrating on this last two down here, 2 or 3, but you can see that they all sort of relate, because from a developer's perspective, we're developing products, we're developing applications and microservices, and microservices and Kubernetes containers are getting more and more popular with our customers. So we're building a lot more functionality in our cloud to cater for all these services, and they all sort of relate in a sense. Though when we're developing microservices and applications, the microservices will be developed by developers that will run inside a container for container management, and then will run inside a Kubernetes for container management inside a Kubernetes platform. So you can see that we do have a very vast array of products, and I'm not going to touch all of these, as I said, just the sort of the bottom 2 down here.
But it's a great slide, isn't it, Chris? Because it really does show how amazingly complex our platform is now, and the amount of different areas we're covering. So yeah, it's, as I say, I love this slide. This is one of the slides from Cloud World, isn't it? So it's just good because it starts to really show how we're covering all aspects of development. Absolutely, yeah,
absolutely. Because I mean, we start with languages, the tools that we develop with. We have the applications and mechanisms to roll out those applications, and then we have all the applications like observability and management around it, security and governance, etc. And they're all combined together to give us a really good platform for development.
Excellent.
So from a container strategy perspective, this is what we really have to offer. So we have our compute platform, and our compute platform, we can run, obviously, bare metal, virtual machines, clusters. We can run containerizations and, containers and Kubernetes on these environments as well. But then we also have our container platform, which is new, and I'm going to talk about that. We have a managed Kubernetes platform, which is OKE, and we have functions. So anything from a, container or microservice or Kubernetes area, we've got pretty much all of it covered now. And now with the release of our container service and serverless Kubernetes, we pretty much compete with every other cloud platform out there in terms of functionality and the ability to create and build applications in a very agile way. So from a what's new perspective, and these are coming soon, we have our container service, which is great from my perspective, because now we can actually offer this service where basically we can just create containers on the fly without having to really know or build a Kubernetes environment. And we've also got the Oracle engine for Kubernetes, which is OKE, but we've got the additional functionality with that, which is virtual nodes. And I'll touch on both of these as we go through the presentation. But these are some of the really cool features that are coming out. And as we go, we're building a new functionality and features in our platform. As we go along, it's becoming a more mature platform, and we're now able to compete with all the other cloud vendors in some of this functionality that they've had it for a little while. So from the OCE container instances. So as I said, this is quite new. Well, this is actually new. It's not actually released yet. But what it is basically a simple and quick way to run containers in OCI without having to build a container or say build a Docker instance or Containerd instance, and without having to build a Kubernetes environment. The container instances basically are built like we would build a VM, but with a couple of differences in that we can now launch these containers using our own images. So like a container instance or container image that you would create within OCI, we have the functionality to create these serverless compute instances using our own images or images that we can download from any repo that's an external repo that you want to use. These instances run on our own Kubernetes platform, so that's abstracted away from the user, but allows you to really quickly spin up a container, just like you would in your standard environment or a standard laptop or server or at home. But we have the ability to do that now inside of OCI. It's scalable, so you can see we can go up to 128 vCPUs and a terabyte of memory to really cater for pretty much any container instance workload that you guys have out there. The price is similar to so from a price perspective, it's same price as a regular compute. So you're only paying for CPU and memory, and you get 15 gigabytes of ephemeral storage as part of that when you create that instance. So some of the features of that, as I said, it's serverless. So there's no need to manage any servers from your behalf. There's no need to manage any Kubernetes environments. That's all taken care of by OCI. We have flexibility in shapes, you can see E3 and E4 shapes at GA, and we have plans to add more shapes as we go along. You can specify the amount of CPU and memory allocated to that instance. So when you create the instance, you can specify the amount of CPUs and memory that you want. As I said, there's 15 gigabytes of ephemeral storage is included per instance. It's simple, fast, and flexible, right? So you'll see, I've got a couple of screenshots of what it looks like, but it's as per pretty much most of the resources that we have in OCI, they're very simple, they're very straightforward to follow and build. It's just like building a VM. You can launch it through your console, through CLI APIs, Terraform, orchestrated the way that you want and how you want to basically provision these container instances. And you can pull images either from our own internal OCIR or external registries. And that's the great thing about container instances, that you can, as I said before, you can use pretty much any image that you want to build these instances and containers from. And then from a security, networking, and observability perspective, which is really important these days, and we've seen a lot of issues with security out there in the industry. We've got strong isolation, secure communications, IAM control. We've got built-in metrics, so we can actually see the performance of our containers when we provision them, just to see from a metrics perspective, from CPU, memory, utilizations, network throughputs. And then we can view all the logging and pull those logs through API into our observability and manageability functionality within OCI as well. And you can see it's pretty much almost 100% Oracle controlled, Oracle managed. So from your perspective, there's really only, go through a couple of screens, click the create instance, and then once that container's built, it's all managed by Oracle on the back end. So from a use case perspective, I guess most people would know from a use case perspective what containers are used for, but in case you don't, it's a containerized app. It allows you to build on a microservice application or move from a legacy monolith style to build into more containerized apps. Containerization is becoming more prolific these days, and there's a lot of organizations now who are maybe not so much adopting containers or Kubernetes, but at least have the plans in place and build the foundations to move their applications to become more modernized, become more agile. So whether it's building and developing new applications or moving legacy applications to become a bit more agile, containerized apps are basically the way that we do that. Ephemeral workloads, and what I mean by that is applications or workloads that don't need preservation of state or preservation of data. However, that is important, and I will touch on that when we talk about Kubernetes. Development and test environments where you can quickly spin up a container to test an application or test a workload. Automation of tasks. You can do, standalone environments. You can do, as I said before as well, you can do containerization of legacy applications. So people who are looking at moving into a more modern, agile methodology, moving into the cloud, having this the ability to create containers inside OCI really provides that foundation for you guys.
And we make it really easy for them to move from their current on-premise Kubernetes platforms across into OCI, don't we, Chris?
Absolutely, because it's all built on open source.
Right.
So there's nothing that's basically that doesn't make it easy, right? So because it's open, because we're using open source Kubernetes in the back end, it just makes it easy for on-prem environments. So you can move your pods and containers from your on-prem that using the same images that we would use inside OCI.
I think that's quite a key thing, isn't it? That with the design process or sort of principles for OCI is that we've used open source. We brought open source products into OCI. We haven't tried to make our own special ones that can only be used in OCI to make it easier for people to actually migrate their current workloads into OCI. So I always think that's a strong point.
Absolutely. Absolutely. And this screen really just gives you an example of what it's going to look like. So as I said, it's not released yet. We don't have an exact date for the release of the container instances, but you can see from the top left, we'll create a container instance, providing things like the availability domain, the shape type that we want to use, specifying the CPU and memory allocation. We can look at the networking, which VCN is going to run in. The next slide on the right, it shows us the container image that we want to use. And we can use, as I said, our own internal registry for those containers, or we can use an external registry or repo. Once we've downloaded that image, we basically, that's it. You click.
And we provide those on OCI too, do we, Chris? So the repo, you can have an external repo, but you can do the registry and repo within OCI as well?
Correct. We use our OCIR registry, so you can upload your images and keep them inside of OCI, and then just download your images from our own internal registry or repo, or we can point to an external registry and download their images from there.
Excellent.
Yep. And then you'll see down the bottom, basically you'll have your containers, your container instances that basically look like standard VMs, right? So from the look and feel perspective, it's like just creating a VM, but they're all running on Kubernetes in the backend.
And all this is protected by our security functionality and services and monitored via our observability management as well. So we can, you can watch all this and make sure everything's running properly and be notified.
We're not sacrificing any security or any functionality because we're running this in Kubernetes, but all our standard security measures, applications and resources and functionality applied to all these container instances.
So to basically get going, you just need an account. You set up a network, and we obviously have a wizard that helps you set that up with your network range. And you set up your security policies, switch on free tools like CloudGuard and those sorts of things to help you protect. Yep. And then you build your cluster and away you go. Yeah.
Away you go. And I guess with container as a service, you don't need to build the cluster because the cluster is already built for you.
All right. One less thing to do. Absolutely. Yeah.
All you do is create the container.
Yeah.
Right? We'll talk about the OKE, which is our Kubernetes engine, in the next coming slides, but from the container service, there's no need to build any Kubernetes platform. It's all done by us in the background. You just create the instance.
Okay, that's really good.
So now we'll go into the container engine. So OKE, which is our container engine for Kubernetes. It's not new. However, there is some new features that I'm going to talk about. And for those who don't know or haven't come across it, it really is our managed service for Kubernetes. It provides us the functionality to basically build an environment or a Kubernetes environment without having to worry about building your own hardware or the software. It's, as I said, it's fully managed. It's reliable. We've got all the built-in management. We manage the control plane, the Kubernetes control plane. The data plane, where the Kubernetes worker nodes run at, will be managed by the customer. But from a instantiation point of view, when we created, it's all the setup and install of OKE is very straightforward. So for those who have played with Kubernetes in the past and built Kubernetes environments, you probably know that it can be quite difficult and complex. It is becoming a lot easier these days, but having this run on OCI, and I've used EKS and AKS and in AWS and Azure, I feel that the OKE environment is actually simpler to set up, and the functionality is fantastic. So it's flexible from the deployment perspective. You can deploy it from the console, from API, from Terraform as infrastructure as code. It's got all the advanced security features built into it. We scan images and signing. As I said, because it's using open source Kubernetes, there's nothing special about it. It runs the same as any other Kubernetes platform that you may have on-prem that you work with in the past.
So running it off my console or my own machine, that's as easy as basically just setting up the security keys and connecting up, is it?
Yeah. So once you go through and set up OKE, it gives you basically a screen is how you connect to the OKE or the Kubernetes instance. Oh. Now you can connect to it either through Cloud Shell, or you can connect to it through your own on-prem laptop or workstation, and we'll give you the kubeconfig commands to run and the security features and basically the SSH keys that you need to actually connect to that cluster. Excellent. Once you do, I mean, there is a couple of prerequisites that you need to have OCI, the OCI toolkit, and kubectl installed on your environment to connect to it.
Right. But I could do this through the Cloud Shell now as well, could I?
You can do it through Cloud Shell. You can connect to the cluster through Cloud Shell.
Or maybe one of our new desktops.
Well, yeah, you can.
As long as I was just thinking that, so it's nice now because you don't actually have to have anything on your machine. You can either connect to a desktop or the Cloud Shell to actually do all this. So you can keep everything actually up in OCI.
Absolutely. You don't need to be on your own machines to connect to it. You can do everything through OCI, whether it's Cloud Shell or whether it's a VM that you would create and use that VM to connect to the cluster.
Excellent. Excellent.
So it's seamless integration. This is one of the great things about it, that we can connect to any service that's running in OCI, whether it's persistent volume claims, load balancer interconnects or load balancer connectivity, container images that either run on OCIR or external container images. We've got the encryption, all the governance in place, the networking that basically is the foundation that we run all our services on. We've got the CI/CD pipelines through DevOps that you can automate the provisioning of applications or the modification of applications, the rolling out of code through our DevOps CI/CD pipeline straight into Kubernetes, all the identity management in place, and we can federate identity through third party as well. Now, you'll see that in the center screen, we've got our control plane and data plane, and I will go that in a bit detail in coming slides. But this is what we have now. So as I said, the control plane is where we manage the management of the cluster itself. So that the cluster master node runs in the control plane, and all the services all the processes that go into things like the etcd, the database, the schedulers, the cloud management and cluster management functionality is all running inside the control plane. The data plane is where our Kubernetes worker nodes sit. So just like a cluster, we have worker nodes, and all our pods run inside those worker nodes. So all the containers that run inside a pod will run inside the worker nodes, and we can scale those worker nodes anywhere from one node to, I think it's almost. I don't think we actually have a limit to how far we can.
I was just thinking, I wondered if there was such a, I mean, I'm sure it's a large limit, but yes.
It's a large limit, yeah. So
and then you can obviously have a load balancer in front of those to...
So depending on the application that you have running inside those pods, you would use a load balancer to connect to and scale out your application across those the pods. And I'll go through a quick demo of that as well. So OKE managed nodes is what, as I said, is what we have now. So we control the cluster control plane. We provision the data nodes and the managed node pool. as part of the installation process, but then it's up to the user to manage those worker nodes. You can add more worker nodes to scale them out as your applications or your requirements scale. So as you need more worker nodes or create more pods, you would create additional worker nodes. You would manage the patching through us on those worker nodes. You connect to those worker nodes and manage it like you would any other Kubernetes cluster. However, the whole provisioning process is simplified because we do it through OCI. Now, the difference, well, as I said, this is what the architecture looks like. So we've got our control plane, we've got our node pool. The node pool includes all the nodes that we have in those, or the worker nodes inside the cluster. So we typically start with 3, and then you can scale that out as your workloads, as your workload requires it or demands it. And we've got automatic scalability now that we can basically, as you can specify the amount of pods that are running inside of your cluster. As you exceed that pod limitation, we can automatically add another node in that cluster and scale it as per your performance requirements. Easily upgrade. It's the control plane is hardened, so you don't actually have access to the control plane. You do only have access to those worker nodes. So as I said, this is what we currently have now, and it works great. It's very simple. And for, as I said, for people who have used Kubernetes in the past, coming to OCI and running OKE is a breath of fresh air, really. Now, moving on to what's new and what's coming into the OKE. So serverless Kubernetes nodes. So basically what they are is, as we saw before, we manage the control plane, but the data plane is managed by the end user. Serverless is basically, we manage the entire stack, right? So the control plane and the nodes are managed by Oracle. So hence serverless. All you do is basically consume the environment or consume the cluster and create your pods and applications and microservices on top of the infrastructure that we've laid for you. So it simplifies the operation of Kubernetes. There's no requirement to connect to those worker nodes or manage them. It's automatic scaling. So as you put on more workloads, we manage the scalability in the back end, and we will scale out those cluster nodes as required. It's seamless upgrades because it's done by Oracle for you in the back end. It's flexible to support all your application requirements. It's the processes shape and memory is vertical scalability, so we can scale them vertically, and we can scale horizontally by adding more nodes into the cluster.
Oh, okay.
So it's really, as you can see, all the yellow is Oracle managed, and then the green part is really customer managed, and that's the application side of it. So
and we'll still offer both options, will we, Chris?
We'll still offer both options, yeah. So for customers who, so we've moved from, on-prem environments where you're managing the entire cluster stack. So you're building the operating system, the Kubernetes platform, the container instances that you want to use, whether it's Docker or Containerd or Cryo. We moved into OCI where we manage that in stack. So we build the cluster for you. So you only manage a component of that. And now we're moving to a level of hands-off, where basically we just, from the customer perspective, you only manage putting your applications and pods onto their cluster.
Look, I mean, I suppose it's like, we have our databases, our Exadatas, for people that, want to run and look after their databases themselves. And then, of course, even with those, we have the tooling, but then, we've then gone to that next level with the autonomous database where it's pretty much hands off. You look after it and use your data in it, and we do all the rest. So I suppose Kubernetes was bound to go the same way, wasn't it, really?
Pretty much, yeah. I mean, it's really just virtualization at a different level. We've gone from monoliths to virtual machines in VMware, and then we moved to containers and Kubernetes. So we're just taking virtualization to the next level. A bit
like our native Golden Gate as well, where, we run the platform. You look after the Golden Gate bit yourself, but the rest of it around it, we'll look after for you. And I know that service is going from strength to strength as well. Yeah, it's just taking a lot of the day-to-day stuff out of the way, but it's tying it into a platform that's fully monitored and secure. So it's a good thing.
Okay, so this is best an example of OK with managed nodes. As we saw before, we've got the service tenancy where the control plane runs, and we've got the customer tenancy where our worker nodes run. But this is what it looks like now, or moving to now. So basically everything is running in the service tenancy. from a user perspective, you just connect to the cluster. And for management, you're just using the Kubernetes API endpoints to connect to those worker nodes and install your application and pods and containers inside those worker nodes. So it's just another level of hands-off that you don't have to worry about managing the control. Even though we've made it easier by OKE in the beginning, we're making it even easier for consumers now.
Cool.
So basically what you get with managed nodes, worker node monitoring, worker node scaling, and worker node patching is done with managed nodes. With OKE and virtual nodes, you don't have to worry about any of that. It's all done by Oracle on the back end.
Sounds great.
So now I'll quickly touch on microservices because they really are all integrated together. So even though a microservice isn't a container, it runs in a container that will run inside a pod that would run inside of Kubernetes.
It's beginning to sound like a Matryoshka doll to me, Chris.
Yeah. Typically, and this is not, it doesn't go for everyone, but typically your developers would create your microservices. They would develop the microservices. They would not typically create the Kubernetes cluster or manage the cluster, but we've got some great developers in our team that can do both, right? But typically you would have your developers creating the microservices, then you would containerize that, put it inside a container that could either run inside of Docker or Containerd without Kubernetes, just to containerize it. But then if you want that additional manageability and scalability and reliability, then you would put that inside a Kubernetes platform, OKE or serverless nodes.
Yeah, makes sense.
And what we sort of started with, and basically from a monolith architecture, for those who don't know exactly what a microservice is, we started by monolith, which is basically one large machine that would vertically scale up, and our entire application stack would run inside that one server. So the components are usually part of a single unit. Everything is developed and scaled as one unit. Now, later on, we do things like modules, where we develop modules within the monolith, which made it a little bit easier. But typically, it's all written in one tech stack. You need to be careful about segregation of teams. So teams working on one module may affect other modules, and it's one artifact. So you deploy, when you're upgrading or modifying, you typically modify and upgrade the entire stack. So whilst that was great in the time, we have moved on, and not all organizations are deploying microservices, but probably a lot are. And the microservices basically break down the application. So it allows you to, write the application as microservices, which basically run inside a container. So it makes it much easier to break down, and the application is loosely coupled. So each microservice is its own application running inside a service. Right,
it makes a lot of sense, doesn't it?
Yeah, and typically we split into sometimes into business functionality. It's more flexible in deployment because you can just work on one component of the application inside a microservice without affecting the other components or without affecting the application itself. It can be decentralized, so you can have the microservice, each microservice is running its own database or using its own database. I guess it would depend on how you architect and develop your microservice. It is easy to maintain, but it can be more difficult as well. So whilst we're talking about some of the benefits of microservices, there are some disadvantages. That we could also talk about. So it can get more complex by creating microservices depending on how large your application is. Security could be a challenge as well. So there are some challenges with microservices, but in general, it does, I think, make it easier for application developers to roll out applications.
But again, because of those things, putting it on a platform like OCI is obviously going to help look after those other layers. So you can basically set those and have other layers handle your security and your monitoring and stuff.
Absolutely. Yeah. OCI just makes it easy. And as you saw with the first slide, we've got a very vast array of a portfolio of products that we can use for developers. They can use all those applications that make it easy for them to develop, to roll out, and to manage applications and the application lifecycle.
Because we're not even touched on serverless functions here as well. So there's, as I say, there's lots of different ways. Plus our low code stuff and all that as well. We've got 2 low code options as well. So yeah, Yeah, we're covering all bases, aren't we?
Yep.
Mm.
So why they're popular? It's agile. The component can be upgraded, replaced, and deployed really quickly. The microservices are scalable, so you can scale individual microservices depending on the application and business requirements. Neutrality, we can implement in any language that's compatible and any protocol. So we don't have to worry about only using one language to write microservices. We can write one in Go, we can write one in Python or in Ruby, or we're not sort of strict on the using one particular application or language. It does take away the complexity. So but it can introduce some complexity as well. So as I said, they're not always, it's not always clear cut that moving to microservices will actually make things a lot easy for you. It can add some complexity. So
you need to, at the end of the day, you always need to design and plan these things correctly. It is a great idea, and you can obviously, it means that lots of applications can use those microservices, so you're not rewriting the code or copying the code. And if something changes in the company, you change that one microservice that they all use, and it's all fixed. It could also break every one of them too, I suppose.
It can, but I guess breaking one microservice won't break your entire application.
No, that's true. That's right. Yeah.
So when we're deploying microservices and containers, as I said, a microservice isn't a container until you deploy it inside a container.
Right.
Microservice is just we're basically segregating the application and we're breaking it up into individual modules or microservices. But then we will build a container out of that. And the process is really, you create a Docker file, you'd create your image from that Docker file, you'd create a container from that image, and then you would push that into a repository or a registry. Right. And that could be in our OCIR registry, or it could be an external registry like Docker or an Oracle external registry as well. Right. So that containerizes the application or the microservice. From there, we can go to the next level of then moving it into a managed Kubernetes platform. So we would, create the cluster. We would install, download our kube config. We would install kubectl to connect to the cluster. We would prepare our deployment, and the deployment is basically going to call the image that we created in this previous slide, or the container image that we created from our microservice, and then we're going to deploy that into the cluster. Once we've deployed into the cluster, then we'll do all our testing of the application. So, and this could be this is part of a DevOps pipeline. It's not really a full DevOps pipeline, but this is really how we'd orchestrate moving a microservice that's being put into a container and then moving that container inside of Kubernetes. Now, the benefit of doing that in Kubernetes is that, as you can see, that with orchestration, we can stop, start, and we can scale the application functionality that we don't have outside of Kubernetes. So when you just containerize a microservice, you can't easily then scale that microservice. Yes, you can create another Docker container, but it's done manually. It's a bit more difficult to scale it up and scale it down. Right. If you want load balancers in the front of that, it makes it a little bit more difficult. If there's interoperability requirements that microservice needs, that container needs, it's not easily managed in an environment outside of Kubernetes. Kubernetes manages all that for you. It provides the high availability. It provides the ability to restart that microservice inside the container if it fails. So it gives you that agility, the functionality, and high availability and scalability that you really need to run an enterprise application.
Excellent.
So, quick demo time. Demo. And all I'm going to really show you here is I've got my Kubernetes dashboard running here.
Okay.
And this Kubernetes environment is running inside of OCI. And I'll show you here. I've got my developer services, Kubernetes clusters. This is my cluster that's running, cluster 1. And you can see here that, these are the metrics. I've got my node pool. So this is the node pool that my worker nodes are running in. And if you click on the node pool, it basically shows you the nodes that have been used to create that cluster. Okay. So I've got 3 worker nodes. I've got my cluster configuration. And I'm just connecting. I've just installed Kubernetes dashboard inside of OKE Kubernetes platform. Right. This doesn't come as default with our deployment. I just install that as separate. So, but this is showing me my workload status. I've got 12 pods running, and my pods are down here. I've got a Postgres cluster, and I've got some Nginx web servers running, and I've got some Nginx web servers running with persistent storage.
All right.
So these can be seen as microservices that are running inside it. Each one of these pods runs this container image. So this can be, you think of them as a microservice. So if I wanted to, I hope everyone can see this screen okay.
Yeah, it's.
Yep.
Oh, that's better. Yeah.
So if I do kubectl get pods, and you can see that I've got basically what's shown here. I've got my Postgres cluster, I've got my Nginx and my Nginx DevOps, which is running persistent storage. So if I want to scale out my Nginx web server,
yeah,
I can do that by doing it either from the command line. So I can do a kubectl edit deployment Nginx. And I can do this on the fly. The things that you can't actually do in Docker on its own, right? Okay. So yeah, this is going to edit the actual deployment. So that's now I'm in YAML, and this is the Nginx deployment that's running inside the cluster. And you can see that I've got 2 replicas running, right? And you can see that that I've got.
And this would be people who do Kubernetes would be familiar with all this, yeah.
Yes. So I've got Nginx here, which is 1, and this is the second pod.
Right.
Right. So I can update this on the fly. And this is where I guess the power of Kubernetes, microservices, and containers all come in place, running inside of OKE. I can scale this now from 2 pods, 2 containers, to 20 pods.
Wow. Okay. Yeah.
On the fly. Right. Done. If I look here, I should have 24 or 22.
All right. So you've seen you've got a big sale coming up, and you want to make your website cope with more traffic, and you literally changed it that quick from 4 to 24.
Yeah. Right. So now I'm running
2 to 20. Yeah.
Yep. So now I'm running 20 odd Nginx instances, and I've got my load balancer sitting in front of that. So if I go,
so you didn't have to do anything there. The load balancer is now balancing across all those nodes as they come up. Yeah.
Correct.
So that's the other nice thing there. So you don't have to then go off and do something else with the load balancer. It's literally just you brought them up and it's starting to use them, and you can service more customers.
The load balancer is created automatically for us inside of ACI. Right. We create a service for an application. So I've created an Nginx deployment. As part of that deployment, I've got a service running, which is this Nginx service. You can see that it's Nginx type of load balancer, which I've specified as type load balancer. And this is my external IP address that it's running on.
Right. Okay.
Right. It configures all that for you. So if I put in this external IP address, there's my Nginx web server.
Okay. And you could, of course, have a certificate on that with certificate manager.
Yeah. But what it also does is that I can see that, okay, I'm hitting a load balancer, but I want to make sure that all these instances that I just created are behind that load balancer.
Yeah, sure. We just want to leave a little bit of time for questions, Chris, so we might want to...
And you can see here, I've got basically 20 IP addresses sitting behind that load balancer, right? So this is my load balancer, my Ingress load balancer, and my endpoints are basically all these.
All right, yeah, I can see that now. Yeah, excellent. Okay, so, that's good. I mean, that's as you say, and this is where it really shows how easily and powerful it is that you can change the configuration and it reacts that quickly, and the fact that it also then filters flows through to the firewall. Sorry, the load balancer as well. Yeah.
Yep. And I can do exactly the same thing, but do it through a DevOps pipeline. So the DevOps pipeline adds that additional functionality where, really, from a developer perspective, if you want to do a CI/CD pipeline, you can you write your code, upload it into a repo or GitHub.
Yeah.
And once it's there, you can basically trigger a call to run this pipeline, which will update my code, and then we'll roll it out straight into Kubernetes.
Oh, right.
I've
Okay.
just got a basic pipeline here.
Yeah.
This is my pipeline, and I've got a deployment. Right. The deployment is using an artifact, which is my so here's my pipeline. If I go into the artifact itself, and I'll quickly do this. Projects. There's my artifact, and the artifact can be a couple of things. So it can be a type Kubernetes manifest, which is what I'm running. It could be general artifact. It could be container repository, image repository. So I could basically point to a repo, and then once my artifact runs, it'll pull down that repo, the image from there, or the code that I've got in there. But what I'm going to basically do is just edit this this manifest, and I've got, as you can see here, I've got 5 Nginx DevOps process pods running.
All right. Yeah.
I can change that to.
Oh, so similar thing, but you're now doing it through.
But I'm doing it through a DevOps pipeline. So I've modified my artifact.
Yeah.
I just basically go here and run my pipeline. Now this is a very basic pipeline, but you can make these as complex as you want, and you can do it. You can have a whole lot of stages inside that pipeline.
Okay.
I'll give it 2 seconds.
Oh, your demo gods are not with you now.
There we go.
Oh, there you go.
Let me just kick off that pipeline.
Okay, they were with you in the end. That's good.
Yeah. So that pipeline is going to go through the whole stages, and use that manifest that I've modified and apply that to the cluster that's running inside of OK.
Right. Okay.
That'll take a couple of minutes to run, and I should see 15 additional pods running inside of my Kubernetes cluster.
Okay.
We're just about
coming up to we're coming up to time now. So okay. How are we?
That's finished. If I check here now, then I should really see. Yeah, there's my addition.
Oh yeah, there you go. There's more. Yeah, it's that quick. Yeah. Wow. Yeah. Okay. That's awesome.
Okay, so that's pretty much it. I guess we can open it up to
yeah. Thanks.
Questions.